Welcome to This Explainer. I'm absolutely thrilled to have you here today because we're going to unpack something that we all use, we all completely trust, but very few of us actually understand. Think about it. Multiple times a day, you step into a metal box suspended in a concrete shaft, just trusting that the heavy steel doors sliding shut behind you are looking out for your best interests. Well, today we're going to uncover the hidden engineering, that fascinating combination of steel and sensors that actually stops those heavy elevator doors from hurting us. It's really a masterclass in redundancy and human-centric design, and I honestly can't wait to show you how it all works. It's the ultimate unspoken fear, isn't it? You're running late for a meeting, you see the elevator doors closing, and you instinctively just throw your hand or your briefcase into the gap. And in that split second, your brain flashes a warning. Wait, will these doors crush me? But what if I told you that an elevator door is deliberately designed, over-engineered, and programmed to stop way before it can seriously hurt you? The answer to this terrifying question is a resounding no, and the incredible technology making that possible is exactly what we're going to explore right now. Okay, let's dive right in. Section 1, the metal trap illusion. Moving on to Section 2, the invisible light shield. So before that heavy metal even comes close to making contact with you, you've already interacted with our primary defense mechanism. Here's the core of modern elevator safety, the infrared light curtain. Imagine a high-tech laser grid guarding a bank vault in a spy movie, or, a series of invisible tripwires. That is exactly what's happening right across the threshold of the elevator. The doors project this invisible grid of infrared beams from one side of the doorway to the other, and it's constantly scanning for any break in the connection. It's basically an unseen force field that acts completely independent of the physical doors themselves. And we aren't just talking about one or two beams here, like you might find at the bottom of your garage door at home. We're talking about hundreds of them. Literally, hundreds of individual infrared beams are crisscrossing that doorway, overlapping to create a highly sensitive, incredibly dense, and completely invisible safety net. Whether it's a small child, a walking cane, or just your hand darting in at the last possible second, this dense curtain is designed to detect the obstruction instantly. It is the first and absolutely most crucial line of defense. But you might be wondering, what if that primary system misses something? Well, that brings us to Section 3, the physical backup plan. Because let me tell you, in the world of life-saving engineering, redundancy is king. If an obstruction somehow manages to get past our invisible laser grid, we rely on physical touch. Modern elevators are equipped with pressure-sensitive safety edges. These are basically physical, spring-loaded bumpers or strips that run vertically right along the edge of the doors. They act as a tactile failsafe. It's an electromechanical backup system that just sits there waiting, completely dormant, until it feels any physical resistance against the closing force of the doors. And this brilliantly illustrates the sheer unyielding logic of the emergency safety mechanism. Step 1, an obstruction actually makes physical contact with the safety edge. Step 2, a micro switch or sensor inside that edge is instantly triggered by the pressure. Step 3, a command is immediately fired to the elevator's main controller, telling the heavy mechanical door operator to instantly reverse the motor. It is a perfectly choreographed dance of mechanical cause and electrical effect, designed entirely to save you from injury. Now, during normal operation, the elevator's computer commands a smooth, controlled closing sequence, optimizing for speed and efficiency to get people to their floors. But the very second an obstruction is detected, whether that's by the invisible light curtain or the physical safety edge, that optimization is just thrown right out the window. The system violently shifts priorities from efficiency to emergency reversal, abandoning the closing sequence entirely. So the crucial point here is exactly how fast this shift happens: 0.1 seconds. That is just a fraction of a heartbeat. From the millisecond that an obstruction is detected, it takes roughly a tenth of a second for the elevator controller to cut the forward power to the motor, apply reverse torque, and begin pulling those heavy doors back open. The speed of this obstruction detection technology is honestly astonishing. You barely even register the touch before the doors are already retreating. Which leads us to Section 4, global rules of the ride. Now, why is this technology so universally reliable? Whether you're in a skyscraper in New York, a hotel in Tokyo, or an apartment building in London, you experience the exact same safety nets. This incredible consistency isn't just because elevator companies are feeling generous. It's actually mandated by strict international safety standards. Organizations around the world have developed exhaustive engineering codes that govern exactly how these redundant systems must behave. Furthermore, these standards dictate rigorous maintenance procedures. Elevators are arguably the most heavily regulated and regularly inspected form of transportation on the planet, ensuring that the infrared sensors and pressure edges we just discussed are always active and never ever allowed to fail. Let's see how this builds over time, because historically, this tech has evolved drastically. Back in the 1800s, we started with basic, manual, or quite honestly, highly dangerous mechanical doors. By the mid-1900s, engineers realized the absolute necessity of adding those tactile pressure edges. But the massive leap forward happened in the 1990s when infrared light curtains became the mandatory standard, giving us our invisible shield. And today, in the 2020s, we're looking at redundant smart systems, elevators that don't just react to obstructions, but actually use advanced sensor arrays and data to predict and prevent them entirely. And finally, Section 5, Myths and Future Innovations. So, despite all this incredible technology, I know we all still kind of hold our breath when we step between those closing doors. So, let's address those lingering anxieties and bust a few common myths. First, yes, if you stick a single finger into a tiny gap at the exact wrong moment, the doors might pinch you. They can for sure feel uncomfortable. But they are mathematically engineered and physically restricted from causing dangerous, crushing injuries under normal operation. The force is capped. Second, remember that those backup systems are always active. They literally never sleep. And finally, future innovations in elevator tech are poised to increase sensor range even further, using things like 3D mapping and AI to track your movement before you even reach the threshold, ensuring the door is open before you even have to break a beam. So, the next time you step into an elevator, maybe take a quick moment to appreciate the invisible light curtains, the pressure-sensitive edges, and the brilliant motor engineering watching your back. It is a true engineering marvel hiding right in plain sight. But it also leaves us with a fascinating question to ponder. What other hidden safety nets do you walk through every day without even realizing? We put our lives in the hands of invisible technology constantly. Thank you so much for joining me to explore this incredible topic. Keep questioning the world around you, and I will see you in the next explainer.